Hi all, my name is Abhilash and today we will discuss a basic question from DBMS, that is, what is the highest normal form that is satisfied by relation R, and using those functional dependencies we will judge whether this relation is in 2NF, 3NF or BCNF. Okay, so let's come to the computer screen and I will explain you everything. Now let's take this problem. There's a relation given R, A, B, C with functional dependencies. A determines B, B determines C, C determines A. Check for the highest normal form which fits the functional dependency in R. Here is the algorithm. Let me state you the algorithm first. First you need to find the candidate keys. Let's find out the candidate keys of the relation, okay, with the functional dependencies. Now if you see here, A determines B, B determines C and C determines A, it means that A plus, which is the A closure, this A closure can get ABC all the attributes in this R. It means that A is a candidate key. But let's say we want to find any other candidate key in the relation. So if you notice that A is present in the right side of the arrow here, so go to this functional dependency, then C can be determine A. Okay, so let's see here, we can write C in place of A. And now we are here. Now C is present in the right side of the arrow here, so we can replace this C with the B. Okay, so we can replace C with B. Now we are here. Now if you see B here, B is present on the right side, but B can be replaced by A, but A is still here. It means there's a cycle. So in this case we have A, C and B as a three candidate keys for the solution. Okay, so we can write candidate keys as ABC. So I've written CK equals to ABC. Now next step is find out prime attributes and non-prime attributes. See, here's the thing. The prime attributes are all the attributes which are present in the candidate key. Okay, it means that prime attributes is ABC in this way, and non-prime attributes are all the remaining attributes present in the relation. Now here ABC is prime attribute, it means that there is nothing left with the non-prime attributes. Okay, the third step is to check for 2NF. Rule is, if partial key determines the non-key attributes, then it is not 2NF. Here the partial key refers like this. Let's say the candidate key is now AB and is determining relation ABC, and the functional dependency is A determines B, and let's say the prime attributes or the key attributes is AC and non-prime attributes or non-key attributes is B. Okay, now in this case when we check the functional dependency, here the A is a part of the key because A is a subset of this whole candidate key. If it would have been like AB, then it should be key attributes. Okay, but here it is a partial key because A is a part of this key and B is a non-key attribute. So if part of the key determines the non-key attribute, then it is not in 2NF. So in this case we check for A tends to B. Here A is a complete key. Okay, here A is a complete key, so we can say that A tends to B is in 2NF. Okay, similarly B is a complete key, it is not a partial key, so it is also in 2NF. And if we're talking about the C tends to A, C is also a complete key, so all the three are in 2NF. Now in the fourth step we will check for 3NF. The rule is, if X determines Y, then X should be a candidate key or the Y should be a prime attribute. For example, if we see this functional dependency, A is a primary key, it is a candidate key, yes it is a candidate key, so no need to check about this condition second, so we can declare it is in 3NF. If we check the functional dependency B determines C, B is a candidate key, yes it is a candidate key, so you can say it, yes it is also in 3NF. If we check about this C tends to A, it is also a 3NF. Okay, now the fifth statement says that check for BCNF. The rule is, if X determines Y, X should be candidate key. If we check this, all the three functional dependencies, you will see that all the functional dependencies are in BCNF, because A is a candidate key, B is a candidate key, and C is a candidate key. So all of them are in BCNF. Now if we compare the 3NF and BCNF, BCNF is more stricter than 3NF. Okay, and in case of lossless decomposition and dependency preservation, 3NF is more powerful than BCNF. So the highest normal form which fits the functional dependency in R is BCNF, because all of the functional dependencies is preserved in this BCNF, because we have written ES for the three functional dependencies present in the relation. Let's take another example with R, A, B, C, D, and the functional dependency B determines C and D determines AB. Okay, this one. We will check for 2NF, 3NF, BCNF. Let's first find out the candidate keys. If we notice the candidate key is D closure, which is ABCD, it is taking all the attributes. So R is the relation with ABCD, so D is the candidate key here, because all the attributes have been determined by D plus. Okay. Now here D is not cached by anyone, or D is not present in the right side, so we cannot have more than this candidate key D. So D is the prime attribute, and non-prime attribute is ABCD, because all the remaining except the D should be the non-prime attribute. Now, okay. Now let's check the first functional dependency. B determines C. Is B is the part of the key? No, B is not the part of the key. Okay, so definitely this should be in 2NF. Now let's check the second one. D determines AB. Is D the part of the key? No, D is a complete key. So definitely this should be in 2NF. So it should be in 2NF. Now let's check the 3NF now. What's the rule of 3NF? The X determine Y, where X should be a candidate key. Is X the candidate key? No, is it not a candidate key? Or C is a prime attribute? No, it is not a prime attribute. It is a non-prime attribute. That's why this 3NF is not satisfied here for this functional dependency. Now let's check the second one. D determines AB. D is a candidate key, then it is a 3NF. But if you notice here, we have one no element here in 3NF corresponding to B determines C. If there is at least one N in this column, so we can declare that it is not in 3NF. Okay, it is not in 3NF, it is in 2NF. So highest normal form that satisfies the relation according to these functional dependencies is 2NF. Let's take another example. Here same relations have been taken, A, B, C, D. Okay, and there's a slight change in the functional dependencies. Only D determines AB has been replaced by CD determines B. Okay, now let's check the highest normal form that fits the functional dependencies in the relation. Now if we find the candidate keys first, ADB plus will give you ABCD, and ACD plus will give you ABCD also. Okay, here prime attributes are ABCD, okay, and non-prime attributes is nothing, means 5. Okay, because all the attributes has been covered, so there is nothing left with the non-prime attributes. Okay, let's check the 2NF first with the rule that the B should not be a part of the key. Now if we see, B is a part of the key. Okay, and if B is a part of the key for any of the keys, because there's two candidate keys for any of the key, and this determines a non-key. Is C is a non-key? No, C is not a non-key, it is a prime attribute or a key. So it means that it does not satisfy the rule of the 2NF. That's why it is in 2NF. Let me explain you again. If this B is a partial key, which is yes, it is a partial key, and it determines C, which is a non-key. No, it is not non-key, so it is in 2NF. Okay, now let's check the CD determines B. CD is a part of the key. See here, the CD is a part of the key, and it is determining a non-key. No, it is not determining a non-key, but it is determining a key attribute, so it is in 2NF. Now let's check the 3NF. 3NF states that B should be a candidate key. It is not a candidate key, but C is a prime attribute, so it is in 3NF. And also B is a prime attribute, so it is also in 3NF. Now also check this. For BCNF to happen, B should be a candidate key, but here B is not a candidate key as it is a part of the key. so it is not in BCNF. And also if you check this CD is also a part of the key, it is not a candidate key, so you can declare it N, no. And since we have at least one N in this column, we can say that BCNF is not valid for this relation with the functional dependencies. So the highest normal form that fits into relation is 3NF. So by using this algorithm we have stated before, you can easily determine the highest normal form that fits in relation with the functional dependencies given in the question. Okay, if you are new in my channel, please subscribe my channel. I will make videos like this. Also press the bell icon for latest information and updates. Okay, if I upload a new video, you get a notification as quickly as possible.